The third chapter of the syllabus is coordinate geometry. What is coordinate geometry? Coordinate geometry is about dealing with different points on the graph and then its respective graphs taken further in the syllabus. Let's see in brief what coordinate geometry is. But before we discuss about the mathematical concept of understanding coordinate geometry, let's apply a real-life situation in understanding coordinate geometry more better. Connecting with real life to understand coordinate geometry more better. So coming to the introduction, what was the need for the mathematicians to come into researching on the existence of coordinate geometry? Or what was the need for introducing coordinate geometry into the branch of mathematics is the biggest question which need to be opened through this opening problem. So let's see the real life situation. For example, I assume this to be a sea. I have the sea, the whole of the sea, in which there's a ship which is sailing by out here. So here is the ship which is sailing by, and the person inside the ship would like to reach to the bank in the nearest position. So his destination to reach to the bank, which is out here, would be just based on coordinate geometry. Interestingly, this is a real life situation which demands for coordinate geometry. So let's see how he estimates the bank through application of coordinate geometry. The ship out here in the sea is assumed to be 2 units, 1, 2, and 3 units. A person standing here would like to see the distance moving 2 units towards this side, and then exactly when the ship moves to this place, then from here the ship needs to move 1 unit down, is how we understand the distance being measured. So the person who is 2 units left and 1 unit down is where he reaches the bank in the destination. So let's see how this is possible more briefly through the graph. So I assume a graph. I assume x and y axis intersecting at origin, and I assume the ship is at the origin initially in the sea, assumed in the sea. Now his destination to reach at point P is identified through coordinate geometry. A person standing here in the ship in the sea would move 2 units, 1 and 2, 1 and 2 units to the left, and then he would move 1 unit down. Is how we understand the opening problem. So a ship which moves 2 units left and 1 unit down, or 1 unit towards south, where we take the direction as east, west, north, south. So I assume through direction that this ship is moving 2 units towards west and 1 unit towards south. Then he reaches the destination of the bank, indicates on the graph that he is moving 2 units to the left of x-axis and then 1 unit down of y-axis, and then he reaches the destination P. So how do we define P in the graph is the biggest question which connects coordinate geometry with real life situation like this. So when I see the ship moving 2 units left, I see that he is moving negative 2 units to the left, and then when the ship moves 1 unit to the south, I see that the ship moves 1 unit towards P. So I locate this point P with x moving 2 units minus 2 units, that is to the left, and then the point P which moves 1 unit down, and therefore this would be -1 and this would be minus 2, because the negative values come on the negative side of x-axis. On the left we have negative x values, on the right we have negative y values, and therefore we have the coordinates of P which come out to be minus 2, minus 1. The ship destination to reach to the bank is when it moves to the point minus 2, minus 1, assumed through origin, is how we connect the real life situation of a ship in the sea to reach to its destination in the bank. There are many such examples other than this through which we understand coordinate geometry more better. An aeroplane moving out with certain distance would reach the airport only by using coordinate geometry. A pilot cannot estimate the airport while for landing down without estimation through the perfect coordinate geometry, is how we apply through real life applications. Many more examples to follow with. Before we enter into understanding coordinate geometry more stronger, let's try to understand the structure of the Cartesian system. What is Cartesian system? A Cartesian system through which we understand the location of points and the graphs and the various other aspects related to the graphs and the points. So let's see in brief how the Cartesian system plays a significant role in the coordinate system or the topic of coordinate geometry. Let's see the Cartesian system. What is Cartesian system? Cartesian system deals with the two lines initially being perpendicular. First, I have two lines which are assumed to be perpendicular to each other, cutting at 90. And I take the horizontal line denoted by x, or this is called x-axis, and the vertical line assumed to be called y, or the y-axis. So the horizontal line in the Cartesian system is referred as x-axis, and the vertical line in the coordinate system is referred as y-axis. It's a rule of the coordinate system. They intersect at one point, and the two lines perpendicular and intersecting at point is referred as origin, generally denoted by this, and this is referred as origin, because it is from where we try to take all the different situations, just like in the ship in the previous example problem, where the ship was assumed to be on the fixed base, that is origin. From where we can identify the comparison of origin with the rest of the points. So the intersection of the vertical axis and the horizontal axis is called the origin. The horizontal axis being called x-axis and the vertical axis being called y-axis, and the point of intersection of those two axes being called origin is the rule of the coordinate system. Let's continue further. Here comes now understanding on what would be the definition for the right side of the origin, and what would be the definition on the left side of origin, and what would be the definition up the origin and down the origin. So each of the four directions have their own definitions as a rule of the coordinate or the Cartesian system. Therefore, I have to define the right side of x-axis, which is positive x-axis. Like I take all the values on the right, which are denoted by 1, 2, 3, 4, 5, 6, and 7, etc. It goes on and on till infinity. And the left side of x-axis is denoted by negative values, negative real numbers like -1, -2, -3, -4, -5, so on and so forth. Similarly, all the values on the positive side of y-axis are defined as 1, 2, 3, 4, 5, etc. And this is called -1, -2, -3, -4, -5, etc. Therefore, I have all the values coming on the right as positive x values, negative x values, positive y values and negative y values. Also importantly, it is very important to note that if I refer to this value 3, it indicates my x is 3 at this position. It's nowhere related to y. When I take, say, this value, then I say this point refers to y equals to -4, but this is nowhere related to x. It is independent of x. So this relates to y and this relates to x, is how we understand the values of x on x-axis and the values of y on y-axis. Also, we note that all the numbers on the x-axis on the right side of the x-axis are positive real numbers, and all the values on the left side of the origin on the horizontal axis are all negative real numbers, with origin being the fixed point of intersection of both the axes. Similarly, all the values on y-axis are also the set of positive real numbers, and all the values on the down of y-axis are also set of real numbers which are negative. Positive real numbers, negative real numbers, positive real numbers and negative real numbers is how we understand the coordinate system, the Cartesian system connected with x and y-axis. Origin, x-axis, y-axis are the base rules of the Cartesian system.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.